For 31 years, the United States Navy has operated submarines in the Red Sea without a single confirmed detection by a non-state actor. Not once. Not by al-Qaeda. Not by Somali pirates. Not by ISIS. And certainly not by the Houthis. That record ended on January 9, 2026. And it didn't end with a torpedo. It ended with a phone call. A phone call from Ansar Allah's military spokesman to Al Masirah television, broadcast live to 14 million viewers. The spokesman read coordinates, depth, speed, bearing. He described the exact position of a United States Navy submarine transiting the Bab el-Mandeb Strait. He was accurate to within 400 meters. That submarine was the USS Colorado, SSN 788, a Virginia-class fast-attack submarine displacing 7,900 tons, carrying a crew of 135, equipped with the most advanced sonar suite in the Western Hemisphere, a boat designed to be invisible. And someone had seen it. I'm your host at Navy Sea Power, where we break down the most critical naval operations shaping global power. Today, we're reconstructing an operation that the Pentagon still hasn't publicly acknowledged. An operation that sent 3 nuclear-powered attack submarines into one of the most confined waterways on the planet. Not to launch missiles, not to gather intelligence, but to solve a problem the U.S. Navy didn't know it had. Because what happened in January 2026 wasn't just an embarrassment. It was a strategic shock. The Houthis, a rebel group operating out of caves and pickup trucks, had built an underwater surveillance network capable of tracking American submarines. And they hadn't built it alone. To understand how this happened, you need to go back 4 months, to September 2025. U.S. Central Command had been running continuous submarine patrols through the Red Sea since the Houthi anti-shipping campaign began escalating in late 2024. The mission was straightforward. Virginia-class boats would transit the Bab el-Mandeb Strait, monitor Houthi coastal radar installations, intercept communications, and provide early warning for carrier strike groups operating in the southern Red Sea. Standard submarine intelligence collection. The Navy had done it dozens of times. The Bab el-Mandeb is narrow, 20 miles wide at its tightest point, shallow in places, less than 100 feet near the Hanish Islands. Not ideal submarine territory, but Virginia-class boats are built for literal operations. Their advanced sail design reduces wake signature. Their pump jet propulsors are quieter than any propeller-driven submarine afloat. At 5 knots, a Virginia-class boat produces less acoustic energy than a school of tuna. So when the USS Toledo transited the strait on September 14, 2025, nobody expected trouble. The boat entered from the Gulf of Aden at 0200 local time. Depth, 180 feet. Speed, 4 knots. Minimal radiated noise. Passive sonar showed nothing unusual. The transit should have taken 6 hours. It took 9. And something happened during hour 4 that wouldn't be understood for 3 months. At 0547, the Toledo's sonar operators detected a brief acoustic pulse. Duration, 0.3 seconds. Frequency, 14.7 kilohertz. It wasn't a biological. It wasn't a commercial sonar ping. It was something the operators hadn't heard before. A short, sharp burst that appeared once, then vanished. The Toledo's sonar chief logged it as an anomaly. Classification, unknown. Possible source, fishing vessel echo sounder, unusual frequency. The report went into the submarine's patrol log. Nobody flagged it for further analysis. Nobody connected it to anything. That was the first mistake. 6 weeks later, on October 29th, the USS New Hampshire made the same transit. Different boat, different crew, same route. At 0612, the New Hampshire's TB-29A towed array picked up an identical pulse. Same frequency, same duration, different location. This time 9 miles further north, near Parham Island. The New Hampshire's sonar officer noted the similarity to the Toledo's contact. He filed a supplementary report with Submarine Group 7. The report recommended acoustic analysis. It was received, cataloged, and placed in a queue behind 43 other sonar anomaly reports from across the Fifth Fleet's area of operations. That was the second mistake. The third mistake came from an entirely different direction. In November 2025, the National Security Agency intercepted a series of encrypted communications between a known Iranian Revolutionary Guard Corps naval advisor in Sana'a and a procurement office in Tehran. The intercepts referenced equipment deliveries to the Yemeni coast, specific items, hydrophones, acoustic processors, fiber optic cable, marine batteries. NSA analysts flagged the intercepts as consistent with coastal defense monitoring equipment. The assessment concluded that Iran was likely helping the Houthis improve their shore-based surveillance of surface shipping, an expected development given the ongoing Houthi anti-ship campaign. The analysts didn't consider an underwater application. Why would they? The Houthis had never demonstrated any subsurface capability. They were a land-based insurgency with modified anti-ship missiles and explosive boats. Underwater operations required technical expertise that Ansar Allah simply didn't possess. Except they did now, because Iran had given it to them. What the NSA intercepts actually described was the deployment of a passive acoustic sensor network, not shore-based radar, not surface monitoring equipment, hydrophones, underwater listening devices, placed on the seabed of the Bab el-Mandeb Strait in a carefully designed grid pattern. According to sources familiar with the subsequent investigation, the network consisted of between 14 and 22 individual sensor nodes. Each node contained a broadband hydrophone, a signal processor, and a data link connected by armored fiber optic cable to a shore-based monitoring station near the Houthi-controlled port of Mocha. The system was powered by lithium iron phosphate batteries, the same type Iran uses in its own Strait of Hormuz surveillance installations. The design wasn't sophisticated by Western standards. The hydrophones were commercial grade, likely modified Chinese-manufactured units available on the open market. The signal processing was basic, threshold detection, not advanced classification. The system couldn't identify a submarine by class or determine its weapons loadout. But it could do one thing very well. It could detect the acoustic signature of a submarine passing through the strait. And that was enough. The Iranians had essentially copy-pasted their Hormuz playbook. In the Strait of Hormuz, Iran operates one of the densest underwater surveillance networks outside of NATO territory. Hundreds of sensors, seabed arrays, and mobile hydrophone buoys monitor every vessel that transits. The U.S. Navy knows about this network. It factors into every submarine transit plan through the strait. Countermeasures exist. Protocols are established. Nobody had considered that Iran might export this capability to Yemen. The intelligence community had a blind spot, and the Houthis had exploited it. By December 2025, the sensor network was fully operational. 14 nodes active across a 12-mile stretch of the strait. Coverage wasn't perfect. There were gaps between sensors, and ambient noise from commercial shipping degraded performance during peak traffic hours. But during low traffic windows, particularly between midnight and 500, the system could detect a transiting submarine with a probability estimated at 70 to 80%. The Houthis tested it. On December 3rd, an Iranian-flagged cargo vessel transited the strait at the same time as a known submarine patrol window. The monitoring team in Mocha detected what they believed was a submarine contact. They reported it through Houthi military channels. No public announcement. Just a quiet confirmation that the system worked. Then came December 22nd. The USS Helena, SSN 725, a Los Angeles-class boat, older, slightly noisier than a Virginia, transited the strait. The Houthi monitoring team detected it within 8 minutes of entering the sensor grid. They tracked it for 41 minutes. They recorded bearing, estimated speed, and approximate depth. They didn't publicize this detection either. They were building confidence in the system, testing it against real targets, collecting data, refining their detection algorithms. And then came January 9th, the Colorado. And this time, the Houthis went public. The broadcast hit like a shock wave. Within 30 minutes, the video was circulating on Telegram, Twitter, and Al Jazeera. The Houthi spokesman's coordinates were close enough to the Colorado's actual position that denial was impossible. CENTCOM issued a standard non-comment. We do not discuss submarine operations. But inside the Pentagon, the reaction was anything but standard. Commander Submarine Forces, COMSUB 4, convened an emergency assessment within 2 hours of the broadcast. The question wasn't whether the detection was real. Multiple intelligence indicators confirmed it was. The question was how. How had a non-state actor detected a Virginia-class submarine in transit? The initial theories ranged from compromised communications to satellite tracking to a lucky guess. None held up. The detection was too precise for a guess. Virginia-class boats don't emit detectable signals during silent transit, and satellite radar can't reliably track a submarine at depth. It took the intelligence community 11 days to connect the pieces. The Toledo's anomalous sonar pulse, the New Hampshire's identical contact, the NSA intercepts about hydrophone deliveries, the Iranian IRGC naval advisor in Sana'a. When analysts finally assembled the complete picture, the conclusion was alarming. The Houthis had an underwater acoustic sensor network. It had been operational for at least 3 months. It had detected at least 3 U.S. submarine transits, and the U.S. Navy had no countermeasure for it, because nobody had anticipated it would exist. On January 20th, 2026, COMSUB 4 briefed the Chief of Naval Operations. The briefing was classified top secret. The assessment was blunt. Continued submarine transits through the Bab el-Mandeb were compromised. Every transit risked detection. Detection risked tracking. Tracking risked targeting. And while the Houthis didn't currently possess weapons capable of engaging a submarine, Iran did. If the sensor data was being shared with Tehran, and intelligence suggested it was, then every detected transit gave Iran a real-time picture of U.S. submarine movements in the Red Sea. The strategic implications were severe. Submarines are the Navy's ace card. Their value lies entirely in stealth. A submarine that can be detected is a submarine that can be avoided, planned against, or in the worst case, targeted. If the Houthis could track American boats through the Bab el-Mandeb, they could warn Iranian naval forces in the Gulf of Aden. They could adjust their own anti-ship operations to avoid submarine patrol areas. They could even attempt to develop their own anti-submarine capability, crude, but the sensor network was the essential first step. The Navy needed to do 2 things. First, continue submarine operations in the Red Sea. Stopping patrols would concede a critical intelligence advantage. Second, neutralize the sensor network. Destroy it, disable it, or render it ineffective. The second objective was harder than it sounded. The sensors were on the seabed, in a strait controlled on one side by Houthi forces. Airstrikes on the shore monitoring station were possible, but would reveal that the U.S. knew about the network, and the Houthis would simply rebuild it. The Navy needed a surgical solution, one that eliminated the underwater infrastructure without broadcasting American awareness. On January 22nd, CENTCOM approved Operation Trident Veil. 3 Virginia-class submarines would deploy simultaneously to the Red Sea. The mission had 2 phases. Phase 1, saturation transit. All 3 boats would approach the Bab el-Mandeb through different vectors within a 72-hour window. The USS Missouri, SSN 780, would approach from the north, transiting south through the Red Sea. The USS Washington, SSN 787, would enter from the Gulf of Aden through the Eastern Channel. The USS John Warner, SSN 785, would approach through the Western Channel, hugging the Eritrean coast. The tactical logic was straightforward. The Houthi sensor network had been designed to track individual transits, a single contact appearing on a predictable bearing at a predictable speed. The system's signal processing was basic, good enough to detect one submarine, not good enough to simultaneously classify and track three. By flooding the detection zone with multiple contacts from multiple directions, the Navy intended to overwhelm the monitoring team, force them to try to track everything at once, create confusion, create doubt, and most importantly, create a window. Phase 2 was the window's purpose. One of the three submarines, the John Warner, carried a detachment from Naval Special Warfare Development Group, DevGru, SEAL Team 6. Their mission: locate and neutralize the sensor nodes on the seabed. The SEALs would deploy from the John Warner using a dry deck shelter mounted on the submarine's hull. They would use SEAL delivery vehicles, miniature wet submersibles, to approach the sensor positions. Each sensor node would be physically disabled, cables cut, hydrophones removed or destroyed. The operation had to be covert. No explosions. No acoustic signatures that the monitoring station could detect in real time. Silent neutralization. Comment Trident if you think this plan could work against Iran's exported technology. The planning phase revealed the first major complication. The Navy didn't know exactly where the sensors were. Intelligence had narrowed the network to a 12-mile stretch of the strait, but the precise positions of individual nodes were unknown. The seabed in the Bab el-Mandeb is complex. Volcanic rock, coral formations, silt deposits. A hydrophone the size of a small suitcase could be nearly impossible to find visually. The Missouri was tasked with solving this problem. Before the saturation transit, the Missouri would conduct a covert survey of the strait using its hull-mounted high-frequency sonar in active mode, a calculated risk. Active sonar would reveal the submarine's presence, but at very short range and very high frequency, the pulses would map the seabed with enough resolution to potentially identify man-made objects. The Missouri's sonar technicians had trained for exactly this kind of bottom-mapping mission. They had 72 hours to find the sensors before the main operation began. January 26th, the Missouri entered the northern Red Sea. Speed, 3 knots. Depth, 110 feet. The boat crept south toward the strait like a predator stalking through fog. At 0134 on January 27th, the Missouri began its survey run. High-frequency active sonar, tight beam, short pulse. The boat moved methodically through the search area, running parallel tracks 400 meters apart. Each pulse painted the seabed in acoustic detail. Rock formations appeared as bright returns. Sand produced a uniform, low-level backscatter. And man-made objects, if they were there, would appear as distinct, hard-edged contacts against the natural bottom. The first 6 hours produced nothing definitive. The seabed was cluttered. Coral heads, debris from wrecked fishing boats, abandoned anchors, and cable remnants created dozens of false contacts. The sonar team cataloged everything, running each contact through classification algorithms. Most were discarded within minutes, but 3 contacts persisted. Contact Alpha. Position: 12 degrees, 38 minutes north. 43 degrees, 19 minutes east. A small rectangular object resting on a flat sand bed at 64 meters depth. Dimensions consistent with an electronics housing. No natural analog. Contact Bravo. Position: 12 degrees, 40 minutes north. 43 degrees, 21 minutes east. A linear feature extending 340 meters across the seabed. 2 straight and 2 uniform to be geological, consistent with a fiber optic cable. Contact Charlie. Position: 12 degrees 42 minutes north, 43 degrees 17 minutes east. Another rectangular object, similar dimensions to Contact Alpha. Located at 71 meters depth on a rocky shelf. 3 contacts, 2 potential sensor nodes, 1 cable. The Missouri's commanding officer, Commander David Hartwell, reported the findings to Com Sub 4 via extremely low-frequency burst transmission. The data was encrypted, compressed, and transmitted in a 0.8-second burst, too short for the Houthi network to intercept or locate. The response came within 4 hours. Com Sub 4 confirmed, proceed with Phase 1. The saturation transit would begin on January 29th. The 72 hours between the Missouri's survey and the start of the operation were tense. Intelligence monitored the Houthi monitoring station in Mocha continuously. Satellite imagery showed no unusual activity. Signals intelligence detected routine communications. The Houthis didn't appear to know the Missouri had surveyed their network. The active sonar had been a risk, but it had paid off. January 29th. 0200 local time. Phase 1 began. The Missouri entered the detection zone from the north. Speed, 4 knots. Depth, 150 feet. The boat followed the standard transit profile, the same speed, depth, and bearing that previous submarines had used. The same profile the Houthi network was calibrated to detect. 43 minutes later, the Washington entered from the east. Speed, 5 knots. Depth, 120 feet. A slightly different profile, slightly noisier, deliberate. And 12 minutes after that, the John Warner entered from the west. Speed, 3 knots. Depth, 90 feet. The shallowest approach, the most dangerous. But the Western Channel offered the best access to the sensor positions identified by the Missouri. Inside the Houthi monitoring station in Mocha, the acoustic data began to cascade. According to sources who reviewed the intelligence assessment of the operation, the monitoring team initially detected the Missouri. A single contact bearing 355, consistent with previous submarine detections. The team began standard tracking procedures, speed estimate, depth estimate, bearing rate calculation, routine. Then the second contact appeared, bearing 095, the Washington. Different speed, different depth, different direction. The monitoring team's procedures didn't account for simultaneous detections. The system was designed for sequential tracking, 1 contact at a time. 2 contacts created confusion. Which one was real? Was one a biological? A false alarm? Before they resolved the ambiguity, the third contact appeared, bearing 260, the John Warner. 3 contacts, 3 bearings, 3 different acoustic profiles. The monitoring team's classification algorithms broke down. The system began generating false tracks, merging contacts, splitting single tracks into multiple ghosts. In the strait itself, the acoustic environment deteriorated rapidly. The 3 submarines, the ambient commercial traffic, and the natural biological noise created a cacophony that the basic signal processors couldn't parse. The Houthi network, designed to pick out a single needle from a haystack, was now looking at 3 needles in 3 haystacks simultaneously. The monitoring team attempted to report. They transmitted a contact report listing 1 confirmed submarine, 1 probable, and 1 unknown. But by the time the report reached Houthi Naval Command, the data was already stale. The contacts were moving. The tracks were drifting. Confidence was collapsing. The window was open. At 0331, the John Warner reached its holding position, 400 meters east of Contact Alpha. The boat settled to the bottom, resting on its keel in 58 meters of water. Engines stopped. All non-essential systems secured. The boat went ultra-quiet. Inside the dry deck shelter, 8 DevGru operators prepared for deployment. They wore closed-circuit rebreathers. No bubbles, no acoustic signature. Their SEAL delivery vehicle, a Mark 11 Mod 1, was preloaded with cutting tools, underwater cameras, and explosive ordnance disposal equipment. The plan called for 3 separate excursions, contact Alpha, contact Charlie, and a cable cut point along the linear feature identified as contact Bravo. At 0347, the DDS flooded. The outer door opened. The SDV eased out of the shelter and into the dark water of the Bab el-Mandeb. Visibility near zero. The strait's waters are turbid, heavy with sediment and plankton. The operators navigated by sonar and GPS, a miniature inertial navigation system updated by acoustic beacons planted by the SDV's pilot. Contact Alpha was 400 meters away. At the SDV's cruising speed of 4 knots, transit time was approximately 6 minutes. The team arrived at 0355. What they found confirmed the intelligence assessment. A black composite housing, roughly 60 centimeters long and 30 centimeters wide, anchored to the seabed by a weighted base plate. A single cable, armored fiber optic, ran from the housing's underside and disappeared into the silt heading northeast toward Mocha. The hydrophone element was visible, a cylindrical sensor protruding from the top of the housing, oriented upward to maximize acoustic aperture. The team photographed everything. High-resolution digital cameras recorded every detail: the housing design, the cable connectors, the mounting hardware, the battery compartment. This was intelligence gold. The first physical evidence of Iran's exported underwater surveillance technology. Then they went to work. 2 operators disconnected the cable using hydraulic cutters. The armored sheath required 18 seconds to sever. A third operator removed the hydrophone element from its mount. A fourth placed a small acoustic beacon near the disabled node, a marker for future reference. The entire process took 11 minutes. They moved to the cable cut point along contact Bravo. The fiber optic line was buried under approximately 15 centimeters of silt. The operators excavated it by hand, cut it in 2 places 6 meters apart, and removed the intervening section. This would prevent simple repair. The Houthis couldn't just splice the cable back together. They'd need to lay new cable. Contact Charlie was the most difficult. Located on a rocky shelf at 71 meters, deeper, colder, and more exposed to current. The SDV struggled against a 2-knot lateral current that pushed the vehicle off course twice. The operators reached the sensor node at 0438, 41 minutes into the mission. They were behind schedule. This node was slightly different. Same basic design, but with an additional component, what appeared to be a small acoustic transmitter. The operators photographed it, then disabled the entire assembly. Cable cut, hydrophone removed, transmitter disconnected. The transmitter was a significant find. Intelligence analysts would later determine it was a short-range acoustic modem, the kind used to transmit data between underwater nodes without a physical cable connection. This meant the network might have nodes beyond the 3 the Missouri had identified. Nodes connected wirelessly, not by fiber optic. Nodes that hadn't appeared on the sonar survey. At 0502, the SEAL team returned to the John Warner, all 8 operators aboard. No injuries. No detected compromise. The DDS sealed. The John Warner lifted off the bottom and began its withdrawal through the Western Channel. By 0530, all 3 submarines had cleared the Bab el-Mandeb. The saturation transit was complete. The sensor nodes were disabled. The mission was, by every tactical metric, a success. But the operation's consequences were just beginning. Subscribe if you want to understand how invisible warfare beneath the waves shapes the power balance in the Red Sea. The first consequence was immediate. When the Houthi monitoring team in Mocha attempted to resume normal operations on January 30th, they found 3 of their sensor nodes offline. The fiber optic backbone was severed. Data flow from the central section of the network had ceased entirely. The Houthis reported the failure to their Iranian advisors. The IRGC naval liaison in Sana'a dispatched a technical team to Mocha. Satellite imagery captured their arrival on February 2nd. Two vehicles carrying what appeared to be electronic test equipment. By February 5th, the Iranians had assessed the damage. Their conclusion, intercepted by NSA, the network had been deliberately sabotaged. Not storm damage, not equipment failure, deliberate human action. The cable cuts were too clean, too precise, too strategically placed to be accidental. Iran knew the Americans had found the network, and Iran knew the Americans knew how to disable it. The second consequence was more complex. The intelligence recovered from the sensor nodes, the photographs, the removed components, the acoustic transmitter, was analyzed at the Naval Undersea Warfare Center in Newport, Rhode Island. The analysis confirmed what planners had feared. The Bab el-Mandeb network wasn't a prototype. It was a production system. The components were standardized, modular, designed for rapid deployment and replacement. Iran hadn't built a one-off experiment for the Houthis. Iran had built a deployable underwater surveillance kit. The implications cascaded through the intelligence community. If Iran could deploy this technology to Yemen, it could deploy it anywhere. The Strait of Malacca, the Suez Canal approaches, the Turkish Straits, any choke point where a proxy ally controlled a coastline. The Houthi network was a proof of concept, and it had worked. Naval intelligence began a global review of known Iranian proxy relationships, cross-referencing them with maritime choke points. The results were presented to the National Security Council on February 14th. According to sources familiar with the briefing, the assessment identified 4 additional locations where Iran could potentially deploy similar networks within 12 to 18 months. The locations remain classified. The third consequence hit the Navy itself. The operation had succeeded, but it had exposed a gap. The U.S. submarine force had no standing doctrine for countering seabed sensor networks operated by non-state actors. Doctrine existed for evading Russian SOSUS-type arrays. Doctrine existed for transiting the Strait of Hormuz under Iranian surveillance. But there was no playbook for a scenario where a rebel group in Yemen could track a Virginia-class submarine using commercially available hydrophones and Iranian know-how. ComSub 4 ordered an emergency doctrinal review. New transit protocols were drafted for the Bab el-Mandeb. Submarines would no longer follow predictable routes. Speed, depth, and bearing would be randomized. Active counter-detection measures, including towed acoustic decoys, would be deployed during every transit. The changes were implemented fleet-wide by February 20th. But the deeper problem remained. The technology was cheap. The sensors cost perhaps $50,000 each. The entire network, 14 to 22 nodes, fiber optic backbone, shore station, could be built for less than $3 million. That's the cost of a single Tomahawk missile. For the price of one cruise missile, Iran had compromised the stealth of the most advanced attack submarines in the world, and rebuilding would be easy. The fiber optic cable could be replaced in days. New sensor nodes could be manufactured in Iran and shipped to Yemen within weeks. The shore monitoring station in Mocha was a nondescript building that couldn't be targeted without obvious collateral damage. The Navy could disable the network, but it couldn't permanently destroy the capability, not without eliminating Iran's willingness and ability to provide the technology. And that was a political problem, not a military one. On February 24th, the Senate Armed Services Committee received a classified briefing on the operation. According to congressional sources, the briefing provoked sharp questioning. Why had the initial detection anomalies, the sonar pulses detected by the Toledo and the New Hampshire, been ignored? Why had the NSA intercepts about hydrophone deliveries been misclassified? Why had it taken the public humiliation of a live television broadcast to trigger action? The Navy's answers were unsatisfying. The anomalies had been lost in the noise of routine reporting. The intercepts had been interpreted through existing analytical frameworks, that didn't account for underwater capabilities in non-state actors. The intelligence community had suffered from a failure of imagination, the same failure that had preceded other strategic surprises throughout history. Senator Margaret Walsh, chair of the Sea Power Subcommittee, reportedly told the briefers, "You're telling me a group that fights with pickup trucks outsmarted the most expensive submarine force in human history because nobody thought they'd try?" The question hung in the air, because the answer was yes. That's exactly what happened. The fourth consequence, the tale that hasn't resolved, is strategic. Iran now has confirmation that its underwater surveillance technology works against American submarines. The Houthis have demonstrated that non-state actors can develop meaningful anti-submarine awareness, and the export model is proven. Technology transfer, training, remote technical support. The same model Iran has used for decades with rockets and drones, now applied to undersea warfare. The Navy's response to this new reality is still evolving. The Undersea Warfare Development Center has accelerated research into autonomous counter-sensor systems, underwater drones that can locate and disable seabed arrays. The timeline for deployment is 2028. That's 2 years away. 2 years during which Iran can deploy networks faster than the Navy can find and disable them. The fiscal math is brutal. Each Virginia-class submarine costs $3.4 billion. Each sensor node costs $50,000. The ratio is 68,000 to 1. Iran can build 68,000 sensor nodes for the cost of one American submarine. This isn't a war of attrition the Navy can win through hardware. It's a war of adaptation, of intelligence, of staying one step ahead of an adversary that only needs to get lucky once. Operation Trident Veil proved the Navy could respond to the threat. 3 submarines, 8 SEALs, 1 surgical mission. The sensor network was disabled. The intelligence was recovered. No casualties, no detection. A textbook special operation. But it also proved something else. It proved that the ocean floor, the last domain where American submarines enjoyed unchallenged dominance, is now contested. Not by China's advanced planned submarine fleet, not by Russia's Yasin-class boats, by 14 hydrophones, some fiber-optic cable, and a group of Houthi technicians trained by Iranian advisors in a building in Mocha. The Red Sea is 2,200 miles long. The Bab el-Mandeb is just 20 miles wide. One network covered one choke point. What happens when there are 10 networks covering 10 choke points? Nobody in the Pentagon has a good answer. Not yet. And in the undersea warfare community, that silence is louder than any sonar pulse.